Now it's time to Professor Dr. Alain CLAPPIER. He's a professor in climatology at University of Strasbourg, and he has been working in air quality in the city of Bogota.
Okay, so thank you. So first I would like to thank you to have invited me today. So I have to say that when I received the invitation, my first question was, what I will present today. Because we did so many things in Bogota about air quality that it was quite difficult at the beginning to choose what I want to present. And finally, I said it's a good opportunity to have a good overview of what we did during 10 years. So the idea is not to show you today very detailed things about the scientific approach we had to study air quality, but to talk more about the benefit we could get from the different projects we had in Bogota during 10 years. So just to explain you what are the problems. The goal of an air quality study is to first understand what are the processes which lead to the air pollution. So the first thing which is important to understand is what are the source of pollutants. And the main source of pollutants is due to the human activities, the fact that we are burning fuels, produce in the atmosphere different kind of pollutants, which are called primary pollutants. And once they are in the atmosphere, these pollutants, they are dispersed by the atmosphere, and they are transformed by chemical processes to produce what we call secondary pollutants, like, for example, ozone or acids. And at the end, all these pollutants, they have an effect on human health or on vegetation growth. So the first idea is to understand all the processes and to quantify the quantity of pollutants which are emitted in the atmosphere. So what we are doing is to use a model to simulate all the processes and also to see how we can reduce this pollution. So the idea is to use what we call an air quality model. So this model transforms the emissions which are released by our activities in concentration of pollutants in the atmosphere. Once we have the concentration of pollutants, we can estimate what are the environmental impacts of these pollutants. And we can try to design strategy to reduce the pollution. That means how to modify the emissions to reduce the environmental impact with the less cost as possible in terms of economical cost. So the first thing we have to do is to estimate the emissions. So how we can proceed? First, we split the calculation into 3 terms. One is we have to estimate what we call an emission factor. Emission factor is the amount of pollution which is emitted per kilometer for one specific vehicle. And we have also to estimate a flux of vehicle in each part of the city. That means in each street segment of the street network of the city. And we have to estimate the length of each segment of street of the city. Once we know that, we can calculate the emissions due to the vehicles everywhere in the city. So how we can proceed to estimate the emission factors? So first we can use a lab. We have a specific lab when we introduce each kind of vehicle into this lab, and we reproduce real driving conditions of the vehicle in the lab, and we measure the amount of pollution which is released by the car. Problems of such kind of approach, it is very expensive. So it's what we are using in countries like in Europe or in the States. But in developing countries, this is not possible to use such kind of techniques. It's too expensive. So one of our first goal was to try to find an alternative method to calculate this kind of emission factors. And it was one of the PhD we made. So it was a PhD with Carlos Belalcázar. He did it in EPFL in 2009. And we find a method where we measure concentration of pollutant in the street, and starting from this concentration, we try to estimate the amount of pollutant emitted by cars. So for that, we need to know the number of cars which is passing in this specific street. We need also to estimate the impact of the dispersion of the pollutant, because for the same amount of pollution which is emitted here, we can find different kind of concentration depending on the mixing of the atmosphere. So to estimate this dispersion, we decide to release a gas. It was propane, because propane is very cheap. So we decide to release a gas in the street and to measure the concentration of the gas at the same time of the other concentration. The main advantage of this technique is that we know the emissions we release, the amount of gas which is released, and we know the concentration. That means we can have a relation between the emissions and the concentration. So we can easily estimate a dispersion factor as a ratio between the concentration of gas and the emission of gas. And starting from this dispersion coefficient, from the number of cars, and from the concentration we measure in the street, we can plot a simple straight line like that. So we can plot all the measurements we have, and we can find the emission factor as the slope of this straight line. So at the end, it's a very simple method. So it's a bit strange to spend 4 years of PhD and at the end to conclude with a simple linear interpolation. But you can believe me, it took time to find such simple things, and sometimes it's very complex to find simple solutions. So once we have the possibility to get this emission factor, we can calculate the emissions. For that, we need to know the location of each street, and we need to estimate the flux of vehicle in every street. So the idea is to use countings of vehicles to estimate these fluxes. So this is the last emission inventory we did in Bogota. This work was done by Jan Robra. So Jan made his master thesis in EPFL in 2010. And this is his result. So here you can see the network of streets in the city of Bogota. He considers different kind of streets. Here it's streets where you have a high level of traffic. Here it's medium level of traffic, and here it's low level of traffic around the city. And at the end, with all this estimation, he could get this result. So here you can see for each cell, the amount of pollution which is emitted hour per hour for all the city. And he did that for several pollutants, like here it's nitrogen oxide, but he did it also for carbon monoxide and all the important pollutants. Once we have the emissions, we have to simulate the effect of the dispersion and the chemistry. For that, we need first to simulate the wind. So the black line here represents the topography around Bogota. So Bogota is here. You have Monserrate here. And this is the Sabana, so the plateau at 2,600 meters high. And this is a steep slope going into the Magdalena Valley. So during the day, we saw that generally the wind is going up, and it is blowing from the west to the east, pushing the pollution in the east part of the city. And this is an estimation of ozone concentration. So the red is the higher concentrations, and the blue are the lowest concentration. City of Bogota is here. So you see that we could identify different parts of the city which are more exposed at the ozone concentration. So in the northeast, we found a maximum of concentration. In the northwest, also a little plume, which is due to mainly industrial activities. In the southeast, this plume is mainly produced by pollution which is emitted during the night and by trucks. So you see, once we have the model, we can play with the model to try to find what is the origin of the pollution. This is one of the advantages of the model. But the model should be validated. That means once we have the results, we should check if the results is valid. That means, is it close enough to the measurements? So this work was done by Rodrigo Jimenez. He finished his PhD in 2004. So Rodrigo initiated the project with Bogota. So he did not make his PhD about that, but he contributed to the project, leading the measurement campaign, which was used to validate our models. So just as an example here, you have the evolution of concentration of ozone during 2 different days. So you see the hours here. The black points are the measurements, and the red line are the results of the model. So you could check that the model is working pretty well, and it can reproduce the general trend of ozone concentration at different places of the city. And once you have the model, so you can understand, but you can also play some scenarios to see what could be the most efficient way to reduce the pollution. So this work was done by Erika Zarate. She finished his PhD at EPFL in 2007. And she was in charge of all the simulation of over the city, and she made the first scenario to estimate the efficiency of different abatement strategies. So here you have the results of 3 scenarios. In the first scenarios, we reduce the circulation of heavy-duty vehicle of 10%. Here we reduce of the circulation of buses of, let's say we eliminate 20% of buses from the circulation. And in the last one, we change the technology. That means we change the fuel used in Bogota at that time for a European fuel, and we change all the vehicles to replace Colombian vehicles by European vehicles. It's a model. So the black line shows you what we call the base case. That means it's the situation it was in 2005. So you have a peak of pollution in the morning because the air is stable, and you have an accumulation of pollution. And once the sun starts to destabilize the atmosphere, it mixed the pollution, and the level of pollution decreased. So the red line is the first scenario, the green one is the second one. So you see that a small reduction of heavy vehicle and buses has an impact on primary pollutant. It reduces a little bit the peak, but it does not have a very efficient effect on air pollution. The blue line represents the last scenario when we change the technology, and it has a huge impact on the reduction of primary pollutants, which are here carbon monoxide and nitrogen oxide. On ozone, which is chemically formed, the impact is lower. That means even in the last case, there is almost no impact on the ozone concentration. So this is more or less the situation we have in Europe now, that with technology we could reduce a lot of our emission of primary pollutants, but we have still a problem with ozone because it is chemically produced. So even if you have a small amount of precursors, it is enough to produce a lot of ozone. So what are the benefits of the project? So first I look at the amount of money we could reach during these 10 years, and I was quite surprised because I found in fact a little bit less of 1 million, but it was easier for me to write 1 million, so it was more or less, let's say, $1 million used in 10 years. Basically, it was paid by Swiss institution as well as a Colombian institution, and also a part of it was paid by French institution. So it starts with the city of Bogota, the EPFL and SDC, so the Swiss cooperation, also Colciensas, and the KFPE in Switzerland. It was done in collaboration first with UniAndes, and after with the National University in Bogota, and at the end, University of Strasbourg also participated to all these projects. So what we did with this money, So we could buy equipment. So there is a gas chromatograph now in Colombia, in UniAndes, which was built by the project. We had also good results in terms of formation. I think it's more or less 6 master students, or Colombian students, or Swiss students, who are formed by this, were educated by these projects. 3 PhD students, so Luis Carlos, Rodrigo, and Erika. It's very interesting to see that Luis Carlos and Rodrigo now are professors in National University in Bogota, and Erika is now working in Bern. She has his own activity. She's still working in environmental problems. We had also interesting results in terms of innovation because we found new methodology to produce this emission factor for low cost. And all what we found can be used in other countries. So in other developing countries, we use it in Vietnam, in Morocco. But it's very funny to see that now even developed countries are interested. In France, for example, because we can produce something for low cost. So it's also interesting for developing countries. And of course, we did several publications in international journals. I mentioned here 7 publications, but things are quite linked with other projects, so it's quite difficult to define exactly the number of publications we made. And we had also a political impact. So in 2006, what we saw in our study is that the fleet of vehicles in Bogota is composed of 5%. Here, these 5% are heavy vehicles using diesel engine. And all the 95% are light vehicles using gasoline. And these 5% of vehicles in 2006, they were responsible of more than 90% of the emission of particulate matter, more than 90% of nitrogen oxide, more than 80% of carbon oxide. That means this small amount of vehicles were responsible of the major part of the pollution in Bogota. So when we published these first results, the administration of the city decided to change the circulation rule, and they applied the pico y placa ambiental restriction to the buses and not only to the vehicle. But I was really impressed, so this is the end of my presentation, but I was really impressed by the presentation of César yesterday. And I have to say, if I really look at what is the main sustainable benefit of all this work, it is not political decision. Because this political decision was valid in 2006, and now they already changed and they improved the decision, even if we stopped to work in Bogota. It is not the innovation, because, okay, now it's interesting to have this new method, but we can expect that in a few years a new method will appear and we will improve it again. The real benefit, I think it is the people, because they are working in Bogota, they are teaching in Bogota, and they are continuing to innovate. So for me, it's like seed, you plant and it grows, and it is the real sustainable results of our project. And it's a pity that when we tried to evaluate the project, we did it several times with the people of the EPFL, with Jean-Claude Bollet here. And I think we don't enough mention this kind of criteria in the evaluation, because at the end, it is the real sustainability of the project. It is the people who can stay in the country and continue to work. Thank you.
Thank you very much. Any questions? No?
Very good presentation. My name is Andres Asmus. Which is the economic impact in this kind of research and development?
Yeah.
I discovered something about World Bank. It's 700 millions concerning this kind of impact of pollution in Bogota.
Yeah. So,
and what is the policy concerning health, public health?
Okay, so there is a first question about the
economic
economical impact.
And after is the impact on policy from the measure.
So about economy, I think this is really still a lack of knowledge. Just to give you an idea, we start in Europe to develop models to try to optimize what we call the abatement strategies using the cost of these strategies. And we start to develop it for local areas and for cities. So it is just starting, let's say start 5 years ago. And unfortunately, at that point, we are not able to apply such kind of model for city like Bogota because of lack of data. So if you want, it's a little bit like for the emissions. We cannot use the same kind of model directly in such country. We have to adapt the methodology. So I think we still need to work on that. And the second question was about the policy. So now it's a bit strange about policy because at that point we could have an impact, a direct impact on the politic, which was interesting because it's more difficult for us to have an impact in Europe on politics because many groups are studying air pollution and the governments of the different countries, they are used to work only with few groups. So that was a real interesting experience for us to have the possibility to discuss directly with the administration. Unfortunately, since now let's say since 2006, it stops because now I am not anymore at EPFL. That means I have a different kind of relation with Bogota. I'm still in relation with the people, but I have almost no relation with administration. That means that they are still taking some decision, but without any real advice or scientific advice. So it's certainly less. Less efficient. But okay, for political decision, you have different factors. The science is only one of the parameter you have to take into account, but it's really a pity that we cannot continue to have this impact. Yeah, so basically what they did, they changed the quality of the fuel. They increased the capacity of refineries to produce better fuel, especially in Bogota. And of course, they need to change progressively the diesel heavy vehicles by new heavy vehicles. This is one of the possibilities.
Thank you, Professor CLAPPIER.